Page 246 is on patterns and nonlinear functions. So last lesson was about linear functions. This is about nonlinear functions. So on the top of the page, we have a table that shows the relationship between the number of steps on the staircase and the number of blocks needed to build the staircase. Copy and complete the table. Is the relationship a function? If so, is it a linear function? So you can see for 1 step we need 1 block. For 2 steps we need 3 blocks. For 3 steps we need 6 blocks. And we could think about further what we would need for that. So if we keep thinking this out, the next one we would need 4 more on the bottom. So that'd be a total of 10. And then the next one we would need 5 more on the bottom from that. So that would be 15. And then what they're doing is they're making these ordered pairs that we could then graph to see what that looks like. So we could take and graph these points just to kind of see what this looks like. That would give us an indication whether it's linear or not. You could also just look at your change in y's and change in x to see if it's the same. So if you graph these 1, 1, 2, 3, 3, 6, 4, 10, 5, 15 is going to be off the chart. But you can kind of see here maybe that those don't actually make a line. It's like if we try to look at that, those are not lining up with each other at all. Okay, I could get a line to go through a couple of these maybe, but it's not going to go through all those points. So this is actually a nonlinear function. And again, we could also do that by looking at, we could see every time that our x is going up by 1 every time, but our y is going up by different amounts. It's going up by 2, it's going up by 3, it's going up by 4, it's going up by 5. So the slope keeps changing on that. It's not the same slope every time, and so that is nonlinear. So a nonlinear function is a function whose graph is not a line. Okay, kind of makes sense. Nonlinear, it's not a line. Okay, so one thing we could do is they might just give you a graph and then say, is this linear or nonlinear? So some examples here. These top ones are examples of linear functions. You can see these are all straight lines. Again, linear function, though, it can't be a vertical line. Vertical line, that's we'd have more than one y value for the same x value. That'd be like our cookie and meatloaf example we talked about before. Can't have more than one y value for the same x value, then it's not a function. These other examples at the bottom here, these are examples of nonlinear functions. Okay, I think you can see those are all not straight lines, and so those would be nonlinear. So if you look at problem 1, the area A in square inches of a pizza is a function of its radius r in inches. The cost C in dollars of the sauce for a pizza is a function of the weight W in ounces of sauce used. Graph these functions shown by the tables below. Is each function linear or nonlinear? Okay, so they went ahead and did that. They took those points and then they graphed them. So on A, you can see that's the pizza area. Look at the radius, look what the area is. And then the sauce cost. And you can see here, graph A is nonlinear. Okay, and that's why sometimes if you wanted to be technical about it, you could kind of figure out, if you had different pizzas, like if you had an 8-inch pizza was this much, a 12-inch pizza was this much. You can't just take the price divided by how many inches it is to figure out which one's the better deal. You actually would want to take the price divided by the area. And the area, it's nonlinear here. So it's not just, taking the price divided by the radius. And then the sauce cost, that one is linear. That one's just 80 cents per every 2 ounces. And again, you guys could also do that from the chart. If it didn't specifically say you had to graph it, you could just say the radius. Okay, radius is going up by 2. And then we could look at what's happening. If you subtract those, you get 37.7. So that's up 37.7 over 2. If you do the next ones, 113.1 minus 50.27, that's 62.83. So the x is changed by the same thing, but the y is changed by a different amount. So that would be a way we could quickly tell, besides having to graph it, if they didn't say we had to, that we could tell that that is nonlinear. So if we look at the got it at the bottom of the page, the table below shows the fraction A of the original area of a piece of paper that remains after the paper has been cut in half n times. Graph the function represented by the table as the function linear or nonlinear. So after 1 cut, we have 1/2 of the paper remaining. After 2 cuts, we have 1/4. After 3, we have 1/8. After 4, we have 1/16. So for this one, probably how they've got this written, normally the top thing is the X and the bottom thing is the Y. They did say to graph it, so I guess we'll do that. So what I'm going to do here is just try and take these points, but the Y's, I'm just going to change those. Since the last one was 1/16, I'm just going to go by 16ths on my Y axis. So this was going by ones, but we'll just say it's 1/16, 2/16, and so on. And so what we can think about is 1/2 is the same as 8/16. So 5, 6, 7, 8/16 would be right here. So 1 cut is 8/16 that we have left. 2 cuts, 1/4 is equivalent to 4/16. So 2 cuts, 4/16. 3 cuts, 1/8 is the same as 2/16. 4 cuts is 1/16. And these points are kind of close together, so it might be hard for us to tell. If you make it bigger, it might be a little bit more obvious. And the book's is looking a little bit different than mine. I'm not sure what they did differently than me, but anyway, it's not exactly a straight line here. And if you did more points, it would be even more obvious that it's not a straight line. So this would be nonlinear. And then part B asks, will the area in part A ever reach 0? And the answer is no. We'll just keep getting, each time will be a half of what it was before. On page 249, the lesson check number 1 says to graph the function, and is the function linear or nonlinear. So it did say to graph it, so we'll go ahead and do that. And then it's asking linear or nonlinear. If we graph these points, then we've got 0, 12, 1, 13, 2, 14, 3, 15, 4, 16. Okay, so if we graph those, if you look at that, those do make a straight line. So that would be linear. And again, just from the table, without graphing it, obviously it said to graph it, so we need to do that. But from the table, we've got an idea here because the y's keep going up by 1 when the x's go up by 1. So it's the same every time. It means our slope is the same. So it's like our slope, change in y is 1, change in x is 1. Our slope of the line is 1 for any 2 points we pick on the line. So it's linear. And number 4, does the graph represent a linear function or a nonlinear function, and explain. So part A is linear because it's a straight line. And part B is nonlinear because it's not a straight line. So this gives you an idea of how to work with patterns and nonlinear functions.